So our next problem is sliding window maximum. Okay, this is tagged as hard, but it is not that hard if you understand it properly. Okay, so we have multiple solutions for this problem. We will discuss it one by one. Okay, so what does the problem states? It states that we have given a nums array and we have given some k. Okay, k is the size of window. Okay, there is a sliding window of size k which is moving from very left to the very right. You can only see the k numbers in the window, and each time the sliding window moves right by one position. Okay, so we have given an array and k is given the window size, so its window size is this one, and we need to return the maximum of each window. Okay, so this will be one window. Okay, this will be another window, this will be another window, this will be another window, and so on. Okay, this explanation is given. Okay, now how we can solve this, let's discuss this. So this is our array and this will be our first window, this will be our second window, this will be our third window, this will be our fourth window, this will be our fifth, sixth. Okay, so what I will do, at every window I will find the maximum. So in first window, what is maximum? 3. So add it in answer. In second window, what is maximum? 3. Add it in answer. In third window, what is maximum? 5. So add it in answer. In next window, what is maximum? 5. So add it in answer. In next window, what is maximum? 6. Add it in answer. In last window, what is maximum? 7. So add it in answer. Okay, so this will be our answer that we need to return. Okay, we need to return the maximum of each window. So the very first approach comes to my mind is, let's start with brute force approach. Okay, so the brute force approach comes to my mind is, I can iterate from this to the starting of my last window. Okay, and inside this I can go through each window. Okay, so I will start from 0 till, let's say it will run till n minus k plus 1. Okay, smaller than n minus k plus 1. And inside this I will run every window. So it will be, let's say it will start from I to k. Okay, till k. Basically it will run till k length. Okay, so put the conditions accordingly. Okay, inside this what I will do, I will find the maximum. So let's take maximum equals to 0. Okay, or maximum equals to array of I. This will be maximum, right? So I will update my maximum here of every window. And after this loop, what I will do, I will put it in answer. Answer dot pushback. Okay, whatever maximum will be there, I'll put it here. Okay, so this will be our brute force approach, right? This is the first approach comes in my mind. I'll go through each window and put the maximum of each window in my answer. Okay, how much time it will take? How much time it will take? See this loop, inside loop, it will take order of k times, right? And outside loop will run for almost order of n minus k times. So it is nothing but order of n only. So the time complexity will be order of n into order of k. This will be order of n into k. Okay, and space complexity, we are storing the answer. So for answer it will take order of, let's take order of n only. Okay, it will take less than n, but it will be almost order of n only, right? N minus k. So we want to optimize this. Okay, we want to further optimize this. So from order of time complexity order of n into k, I want to reduce it to, I can reduce it to order of n log n or something, and then I can think of order of n and so on. Okay, so let's go through this. Okay, let's go through this. So I can use priority queue. Okay, how I can use priority queue? How I can use priority queue? See, I want maximum of every window, right? I want to find maximum of every window. So I can use heap. Okay, I can use heap property. So let's discuss that also. Okay. Okay, so let's discuss the another solution which is heap based. heap based, or I can say priority queue solution. So this is our array. Okay, now what I will do, I'll again keep on pushing the elements, okay, until my size. So I'll push 1, okay, I'll push 3, I'll push -1, like that. After this, what I will do, when I come to here, okay, my PQ size is 3, so it is full. So what I need to do in this window, I need to return the one answer. Okay, so when I reach this property, when I reach this property equals to k, what I will do, I'll put this, I'll put the PQ top in answer. Okay, PQ top in answer. So this 3 will be in answer. Okay, so this is our answer. I'll put 3 here, right? Now after this, what I will do, when I go above, okay, when I go above, now what I want to do, I want to remove this, I want to remove this from priority queue. Okay, I want to remove this from priority queue. Why? Because now my window is this one. So there is no direct function in our priority queue which can delete particular element from priority queue. Okay, priority queue always delete, priority queue always delete from my top. Okay, I can always delete from top. So storing the elements only will not give you the answer. Okay, what we need to do, we need to store something else also along with this. Okay, we will do sorting on the basis of elements only. Okay, but we want to remove out of bound elements. Okay, so we'll also insert our indexes also. Okay, so we'll use indexes also. We'll take a pair and its index was 0 1 2 3 4 5 6 7. Okay, so one index was 0, 3 index was 1, and -1 index was 2. Okay, and as this is max heap, so in max heap it will store in max heap order. Okay, so in max heap order it will be stored in this way. This is maximum and we are storing the index also. Okay, so what I will do, I will check, I will check here. Okay, if my top element is not in range, then remove it. Okay, now what I will do, in this window I will insert this one. So I will insert -3 comma 3. Okay, and this will be balance. So after balance it will be, so after balancing my heap will looks like this. Okay, now in the next window, my next window will be this one. Okay, and I will check the top. So my top index is 1. Okay, top index is 1, but my range starts from 2. So I will pop this out. I will pop this out. So in this window, I will push 5 along with the index. So push 5. Okay, its index is 4. Now I will copy this in answer. Okay, so this will be 5. Now move the window. So my next window will be this one. Okay, in this window we have the index 4. Okay, it lies in this window. Okay, so no need to delete anything, no need to delete anything. So again in this window also my answer will be 5. Move forward, move forward to this window. In this window our top is at index 4. Okay, so my top is in range. Okay, my top is in range, so no need to remove this. Now what I will do, I will push the next, I will push the next element. So it is 6 and its index is 6. Okay, and now after pushing this, I'll put the top element in answer. So my top element is nothing but 6, so put 6 in answer. Okay, now move forward. So this is my last window. Okay, so it contains 3 6 and 7. Now my top index is nothing but 6. Okay, these are indexes and these are elements. Okay, so my top index is nothing but 6 and it is in the range, so no need to pop. Okay, no need to pop. I will only pop when the top element index doesn't lies in this range. Okay, so after this I will push this element. So I will push 7 and its index is 7. Okay, and after pushing, I will put the top element. I will put the top element in answer. So this will be 7. Okay, and after that, what I will do? I will return the answer. I will return the answer. Okay, and this is our maximum of every window. Okay, maximum of every window. Okay, so what will the time complexity? The time complexity will be in heap at max. See, in this example, 1 2 3 4 5 6, what will happen? It will store all the elements with its index 1 comma 0 2 comma 1, then 3 comma 2, like this. Okay, so it will store all the elements. So we need to search in the heap of order of size n. Okay, so at worst it can take order of n log n, where this n will be the my priority queue size, pq size. Okay, so usually we write it like n log k, because every time my priority queue size is different. Okay, so at max, whatever maximum my k will be, that will be the time complexity of this algorithm. So what can happen, that every time we can push the element. Okay, every time we'll push the element, and here I will check from this heap. Okay, so in the previous problems, what we were doing, we are taking a constant size heap. Okay, we are taking at max k size heap, but in this problem we are not taking k size heap. Okay, we are not taking k size heap. Why? Because in priority queue there is no such function. There is no such function which can remove element at particular index. Okay, so for that, what we are doing, we are removing element only if top element doesn't lies in range. Okay, because we are working with top element only. Okay, we don't care about the rest element. So here, -1 0, we don't care about this. Okay, we are caring about maximum at each window. Okay, so first we are checking that this top element lies in our range or not. If it is lying in our range, then what we will do, we'll push current element and we'll put it in the answer. We'll put current element in answer. If it is not lies in range, first just remove this, then put our current element. Okay, if it is lying in range, then it can be answer, right? So here in this window also 3 was answer. In this window also 3 was answer. In this window 5 was also answer. In this window, after inserting 3 also, 5 was our answer. Okay, so we are removing from priority queue only when it is not in our range. Okay, that's why we are storing index along with the element. Okay, otherwise there is no need of this. Why we are doing this? Because we want to remove element from particular index. Okay, so at top we are checking whether this element lies in our range or not. Okay, rest we don't care. Okay, so this is all about this problem, and let's code it quickly. Okay, so let's take a priority queue, and we'll take a pair of int comma int pq. In pq we'll store first element and then its index. Okay, now what we are doing, we are pushing element, so we will run this. Okay, int I equals to 0, I smaller than, let's take the size also, int n equals to nums dot size. Why I'm using this for loop? Because I need index. Okay, so again, if pq dot size is empty, then put pq dot push. I'll put the element position nums of I, and I'll put index I. Okay, after this, what I will do, I will remove the element if not in range. While pq is not empty, and if pq dot top, okay, dot second is, if it is less than, let's say, I minus k plus 1. Okay, if that is the case, then what I will do, pq dot pop, and I will push my current element, that is nums of I along with its index I. Okay, and after pushing this, what I will do, I will take a vector answer. So vector int answer, and in answer what I will do, answer dot push back pq dot top dot first. Okay, and I will return the answer. Okay, this will be same mistake. So what I will do, I'll put a condition here. Okay, so what I will do, my first answer will start from here. Okay, so I will write if my I is greater than k minus 1 or equals to k minus 1. Okay, so from here it is 2, k minus 1 is 2. Okay, so then only I will insert. Let's run this. Okay, let's submit this. It is accepted. Okay, so why I have put this condition? Why I have put it this condition? Because otherwise it will store all this one 3 minus 1, but I want to store the this one. I want to store the maximum of this one. So my first answer will start from this, and then at every window I will get one answer. Okay, so my I will be greater than equals to k minus 1. Okay, if my I equals to 2 and k is 3. Okay, so 3 minus 1 is 2. So from second index I want my answer. Okay, if you don't want to use this, if you want to avoid this confusion, what you can do, you can store first k characters before. Okay, like this, int I equals to 0, I smaller than k, I plus plus. Okay, and pq dot push nums of I comma I. Okay, now you have pushed k elements, and push answer dot push back pq dot top dot first. Okay, and you can run this loop from k. Now you can avoid this condition. Okay, now you can avoid this condition. Okay, let's run this. Okay, so what I have done, I have taken this first window before only. Okay, and I am running this from here itself, from k itself. Okay, and now I will compare and put it in the answer. So if you run this, if you submit this, this will be accepted. Okay, so if you get confused here, what you can do, just take one window separately and start from next onwards. This approach is also not very efficient. Okay, we have one more approach using dq. Okay, so in priority queue, what we are doing, we are running this loop. Okay, we have no particular function for finding the element at particular index in priority queue. Okay, but we can use dq. In dq we can push and pop from both ends, push or pop from both ends. Okay, so what we can do, we can pop element from like front. Okay, which are not in range, which are not in range. Okay, so everything will be same, just this condition will change. Okay, and one more condition will occur. So just try to do using dq. Okay, just try to do it using dq also. So this is the code for dq also. Okay, this is step, in this step what we are doing in priority queue, we are running a while loop. Okay, but in dq we can just do directly using front. Okay, and after this what we are doing, we are running this while loop. So what we are doing, we are removing the elements which are less, okay, which are less than my current index, so that I can get the maximum in the front. Okay, because in dq there is no such property of max element, right? So in this step what we are doing, we are removing elements less than current element in dq. Okay, and similar to priority queue, we are pushing element, and same, this step is same as priority queue. This step is also same as priority queue. We are following this step, why? To follow the property of max. Okay, to putting the maximum value at front. Okay, so this will take how much time? It will take one loop. Okay, so it will take order of n time only. And space it will take how much space? So at max there will be k elements in dq. Okay, so the space will be order of k only, right? Answer size will be what? It will be order of n only, right? So it will take order of n minus k space, but you can say order of n only. Okay, so this is the most optimal one. We have discussed brute force, we have discussed priority queue, we have discussed DQ. Okay, I'm not going into much details of DQ because see mostly it is same as priority queue. Okay, we are just using this condition for front and this to following the max property. Okay, so this is all about this problem, and we have done a lot of problems on heap. Okay, so this was all about heap as well, and I hope you understood it. Okay, so in heap, where we can use heap, so whenever there will be kth largest or kth smallest, you can think of heap. Okay, or whenever you want to find maximum every time or minimum every time, so you can think of heap. Okay, so in majority problems, what happens that there are much more optimal approach than heap. Okay, so in many places we can avoid heap as well, but in the place where our solution will be like n log n or something, so we can think of heap also. Okay, so this is all about the heap, and I hope you understood whatever problems we have discussed. If not, just go through once. Okay, just go through the heap sort lecture and go through the STL lecture and then go through this lecture again. Okay, everything will be clear. So start from heap sort lecture. That is the basic one. If you forget to watch that, please watch that lecture. Otherwise, you will forget so many things here. Okay. So in heap sort lecture, I have teached in many detailed manner. Okay. In STL lecture, I have discussed how to use the priority queue. Okay. In this lecture, we have discussed many of the problems. So you can solve a lot of problems also, but these are the from easiest to the hardest one. If you understood this, then you can solve majority of the problems. Okay, I have discussed almost all the variations using heap. Okay, I took min heap, I took max heap. Okay, I took pair also, how to take pair, how to take values inside this pair. Okay, so first one, take the first one on which you want to sort. Okay, so this is all about this lecture, and let's meet you in next lecture. Okay, till then, bye bye, take care.